Hello again and welcome to another game dev video. Something I realized I didn't say in my last video was how valuable I found it when I reopened my project after more than a year to actually go back and look at my old YouTube videos again. Watching through them helped me remember so many things, but also watching through them made me realize that I don't go into a great amount of detail about anything. So in the interests of future-proofing this, and also, in case I want to go back and see how I did something for a future project, or in case this one gets shelved for whatever reason again, I think it's an excellent idea to go back in and document my coding process. And we're going to start with the lighting, these lights here, like the ceiling lights, how the code actually works. But before I do that, my light leak issues are almost a thing of the past. Here, you see how nice and dark it is here. This bit here, you can see a little bit of artifacting going on there. You'll notice I have these like big ugly square things going around, and these are in every room now, almost in the entire house. I will experiment with these later on, see if I can get them looking a little less thick. There's a process called voxel wrapping which smooths off the corners, which might work, but it also might make them less effective at doing what they're supposed to do, which is block the light. Let me go to the worst area, which was this tunnel here, and you will see again some minor artifacting here and there, but look at that, pitch black. If you watched my last video, you'll realize what a massive improvement that is. Did it in the garage as well. The garage is always going to be a slight problem because of these doors. They're very thin, so they will let some light in, and they are pre-built assets that are animated because they're, rolling doors. If you see there, you'll see how they're animated and how thin they are. So yeah, these are always probably going to be a problem, but overall I'm very happy. This is a lot better, performance is decent, lighting problems are mainly a thing of the past. So with all of that in mind, let me get, this is a build of the game, by the way. Now there as well, you see the along the corners of the floor. So yeah, the problem is not gone, but it's 90% of the way there. I'm pretty happy with that. So yeah, with all of that in mind, I'm going to exit out of the build of the game, which I did last night, the current build, and get back into the editor so we can look at the lighting blueprints. So here we go. Okay, so here we are back in the editor, and we're in the main entrance hallway of the house. Here's the switch that controls this light. I don't know if you saw that little spotlight appear on the wall there. That's another lighting issue. There's a few places in the house that still do that. I'm still working on that as well. Like I said earlier, though, overall the lighting is way better. So this is the light switch that controls these lights. There you can see they're off and there they're on. That's not all we can do with lights though. We can trigger a power failure. So you'll see the light in the next room is on as well. Power goes out. And then if we try and switch the lights on, now you'll notice the little red guide light is also out because there's no power. So if I do that, you'll hear click, click, and the character will say the power is out. So let's put our flashlight back on again. The way to fix that is to go down into the basement. I can trigger this with a key press, but it's important that I actually show you this because there's a little piece of code that pertains to it as well. So now we're in the basement, and here is the mains power. So when we switch it on, you'll see it's got this, I like the idea of the power switch having this like big long lever. So when you turn it on, you're gonna pull it down. So when the power trips, it goes off immediately, but when the power comes back on, it takes a second. And the other thing that the power does, let's just get out of here. The other thing we can do with power is affect the lights individually. So this is separate from a power failure. This is individual light addressing. So if I hit this button, only the light that I've selected will go out. And I select it in code, and I can turn any individual light off at any time, or any group of lights at any time, without affecting the state of the other lights or the state of the master power switch, which is pretty cool. And then the last thing, of course, is the flickering. Now, most of this code is handled in the lighting blueprint, or in each individual lighting blueprint, but some of it is done from other places. Today, we're going to focus on just the individual lighting blueprint. So let's go and have a look at it now. Right, so to start, we have something called event begin play, which is literally as the game begins, anything attached to this node will run. And then we have something called parent begin play. The reason we have parent begin play is because these blueprints, basically any object that you can interact with in the game, is a child blueprint of something called this, BP Interactive Object Base. And all this does is run all of this code at begin play. And because it runs in the parent blueprint, it runs it in every single blueprint, except if you have stuff running off event begin play in your child blueprint, because that bypasses this event begin play and only runs what's attached to here. But by putting parent begin play in between the begin play in the child blueprint and whatever code you want to run, it makes sure to refer back to this and run all of this code first. And that took me a long time to figure out, and I was re-adding stuff manually. There are still code fragments in my game that have this rookie error in them that I must get around to fixing, where instead of just putting a parent begin play node in, I'd go and copy all of this code and then stick it into each blueprint individually. Very messy and very stupid. But yeah, I'm still busy fixing that stuff. So all that happens in the parent blueprint is we just create references to stuff. Now all of this other stuff we'll get to. These are just references to the player blueprint, the notify widget, the feedback widget, the game mode blueprint, player controller blueprint, and game instance blueprint. These are all important things that these blueprints may or may not need to refer to. And by doing casts here, cast just allows you to talk to another blueprint. By doing all the casts in advance and setting those things, the return values, as variables, instead of having to cast to a BP player, this blueprint over here, every time I want to refer to it, I have a variable here called player controller, and that makes it a lot easier and a lot quicker and also a lot more efficient. So back here, once we've run begin play in the parent blueprint in interactive object base, we get to the sequence of events here. Firstly, we set the light intensity as a variable. That's to do with the flickering that I showed you, that we will get back to. The second thing we do, I don't know why they're in this order. Oh, okay, I think they're in this order because we need to set an event dispatcher event here, which we need to do early in the code process, but I'll get back to that. And then here, we just set the light on or off based in the state stored in game instance. Our game instance is a blueprint here, and you'll see there's no code in it, just a bunch of variables. And the reason we store stuff or refer to stuff in game instance is because game instance is the only blueprint that doesn't reset every time you start the game or load a new map. Well, it'll reset every time you start the game, but when you load a new map, whatever's stored in here stays. It doesn't get reset. This makes it very handy for storing stuff like save data, and in this case, I'm using it to store the states of lights. So and I really don't have that many cases of it yet, but it's something I will be getting to. If the player, let's say, goes to sleep or leaves the map and goes to another area and then returns, we want the game to remember which lights the player had switched on, which doors they had left open. And this is where we store all of this stuff. So at the beginning of play, the game goes and looks in game instance and checks to see if this particular light was on before, and if it is, it sets it back to on. Because, like I said, it'll reset if you leave the map or load a new map. it's important to note that when I was working on this game, I was pretty much learning as I went. And it only occurred to me later that I could use a struct to store variables instead of just a series of Boolean variables like I did for the light state. So the light states are all stored as a series of like on-off variables or Booleans. And then the states of the doors, now I'll get into the door code at some point as well. But yeah, the states of the doors and the contents of your inventory are stored in a struct. And here they are. You'll see all the variables are just together. You'll see some of the doors are marked with text. That means I want those doors to be opened when the game starts. It's the idea, like if you go into a house, not every single door is going to be closed. Some of them are going to be open. And I won't be doing the same thing with the lights because given the context of the game, you're looking after someone's house and they're not there. So obviously they'll have switched all the lights off. They won't necessarily have closed every door in the house, particularly in a big house. So yeah, what I should have done is use a struct to store all of the variables. Here's the one for inventory. Actually, I can show that quickly. Go here. And the struct itself, let's look at the door states one. Yeah, it's the same thing as what I've got before, except instead of each like a long list of variables, all the variables are stored in one place. The struct is like a container for chucking variables in. And this is not even the best use case for a struct. Like you could use, like for the inventory one, the idea is they're all different types of variables. So we have text, we have texture, we have static mesh, and Booleans like all together in one place. So yeah, it doesn't really matter that much. But in hindsight, I'm wishing that I had referred to all of these lights. Yeah, I'd put them in a struct instead of having them all loose in here. But yeah, so that's the next thing that the code does. So yeah, the game then looks at the game instance to see was the light on or off before, the last time the player left the map, and then sets it back to its original state. Okay, let's get back to the mains power control section. Now remember I said BP Interactive Object Base, the parent class of all of the object blueprints, sets a bunch of references as variables. And here's a perfect example. If you look here, here's the reference to player. And because it's been set there as a variable, here when we need to get stuff from the player blueprint, we just drag it in. It's already there. Like if I say player, and I scroll down, it should be here somewhere. There we are, get player or get player controller. So instead of having to do that cast again, I can just drag this in and now I have a reference to player. So why are we getting a reference to player? Well, the first thing we're doing here off the code is we're binding an event to an event dispatcher. If we go to open player, you'll see here's the event dispatcher. Now, an event dispatcher is, what it is imagine you are subscribed to an email, like an email newsletter. The guy who sends that email newsletter out every month doesn't have to email it individually to every single person on the list. He just clicks send once and it gets received by like 100,000 people or whatever. And that's what an event dispatcher is. Everywhere you have a bind event to event dispatcher in every blueprint. So I have it in all my lights, for instance. All my lights will have this bit of code in. Then as soon as this event dispatcher here is triggered, and we'll get back to the player blueprint, don't you worry, there is, as you can see, a lot of code in here to discuss. But as soon as that event dispatcher is triggered in player, it'll trigger every single place where an event is bound to it, like here in the individual light blueprint. And what that event does is, well, it does a bunch of stuff. Firstly, we check to see is an individual light being addressed. And if it is, we go up here and you'll see here I have it's like a little bit of test code really. Although this will kind of work in final game as well. So we're checking here to see if the individual light's name has been set. And here we set it. So you can see I've got it set to entrance hall now for testing purposes. So if we go back into the game now, I've already switched the lights on, and I use the trigger to address the individual light, you'll see that that one switches off. Now, I could also, let's say we want the light in the other room to get switched off. That's easy enough to do. What we need to do is, let's just open this window again. And we'll go and find actors, lights, living room. Which will be here somewhere. Living room lights. And we'll go and check here to see what the light's name is. It's just called living room. So if we go back into player blueprint and we set this to living room, we launch the game again. This time when I hit the individual light addressing switch, the light in the other room will switch off, like so. Okay, so that's how the individual light addressing works. Then once it's made sure, I mean, you can see it's just checking to see if the name of this light is the same as the string of text in the player blueprint that tells it which light is being addressed, and then that gets connected straight into the code that actually deals with the lights, which I'll get to in a second. But we're still on mains power control. The next thing we do is we check to see, are the lights in the process of flickering? We'll get back to this bit of code in a bit. If the lights are not flickering, we check to see, is the mains power actually on? If the mains power, because remember this bit of code deals with that master switch down in the basement, or in the cellar rather. I had to pause the video there and go and trace the code because I wasn't sure what was going on. This stuff is complicated. So if we now go to and have a look here, so the game will check to see if mains power is on. If the player blueprint has set mains power to off, then what we need to do is turn this off. So if mains power is set to off, then we go to this bit of code here. Now what we're doing here is we're setting the visibility of the main light in the blueprint and the little red light. If I open here, this is the diagram of the blueprint. Here's the... Okay, well, I just had some kind of weird crash where like nothing would work anymore. So I had to restart everything, so hopefully we can continue. Now, where were we? Inside the viewport of the blueprint, you can see everything is kind of laid out here the way the blueprint appears in game. So the light switch is over here with the interact collider, which allows the interact message to pop up on the screen. We haven't gotten to that bit of code yet, but we will. This is the light switch, and here you will see there are two emissive, there are two materials, one of which is emissive and the other one of which isn't. And it's basically just two little cubes, and one of them shines red and the other one doesn't. So the idea is when the lights are off, the little red light shines so that you can see where the light switch is in the dark. And when the other one is on and the main light is on, then obviously the little red light doesn't need to be on. But in the case of a power failure, both the little emissive red light and the main light, which is up here in the ceiling, need to be off. In addition to the emissive material of the little red light, the big light, you can also make the center of the material emissive, which is how I've gotten this effect. Let's just go back in here. Hopefully this will work this time and not crash again. Let's see. Come on, there we go. When you switch this on, you'll see that the material that makes up the glass bit of the light glows in addition to the actual light, because lights are invisible in this game. You need to have something that looks like a light and then put a light near it to actually cast the light. So yeah, now that we've covered that, we can go back to the blueprint, if you set the mains power to on in the player blueprint, and this is only one of the places where we will do that, there are a bunch of cases, but we'll get to the player blueprint at another time. Suffice it to say that here, in this bit of code, we have, you can see what the code comment is. This is another function of the lights, but like this takes place outside of the actual lighting blueprint. If the player switches too many lights on, the power will trip, and we can adjust all of the variables with that. But yeah, as a result of this code, we trigger a power failure, so we set mains power to off. So when the event dispatcher is called, we check to see if the mains power is on. If we've switched mains power to off, that means we need to go and switch the lights off. If we've set mains power to on, means to switch the lights on. Now you'll notice there's a delay here of 0.8 seconds, and that is just to compensate for the little switch in the basement that I showed earlier that like has travel time when you switch it back on. So that's what the delay does. And then we check to see, is the light on or off? Now this just means, was the light on at the time when the power tripped? If the light was on before the power tripped, we need to switch it back on now that we switched the mains back on. So here's where we do that. So this rect light is the main light in the ceiling, and then the red light is the little red light on the light switch. Here we want to set the visibility of the rectangular light to on and the red light off object to on, because obviously the red light is not going to be on when the light is on. And then we set the visibility of the emissive material red light to off. You'll see that it says new visibility. Then this create dynamic material instance just means that we set the material of the actual light in the ceiling to be emissive, and there we set the parameter emissive strength to 20. And then if the light was off before the mains power got tripped, we just set it accordingly, so it's the reverse of that code. And then on this branch of the code, if we've set mains power to off, we just do the same thing again in reverse. We set the visibility of, here we set the visibility of the red light and the main light to off. That's the reason why we need to have this code running separately, because it's slightly different than the way the lights will work when the mains power is on. Then there's this light flicker code. We'll look at this quickly. Here we're going to check, this branches off from here, like lights flickering. I'll get to the actual thing that calculates how the lights flicker. This is one flicker loop. So the code for a flicker loop exists in each lighting blueprint. So firstly, we check to see, is the light on? And then we check to see, is the light flickering state on? Now we get that from player as well. These are all variables related to how the flickering code in the player blueprint works. Here we have a minimum and maximum value of how much the light is going to dim, and we're going to get a random number between those two values. Again, this all comes out of the player blueprint and it's part of the flicker code. Then we take the light intensity, we divide by the result of that random float in between those two values, and we set the intensity. If the light flickering state is on, we set the intensity of the light to that value over there. And again, create dynamic material instance. So we're setting the intensity of the light and the intensity of the emissive material that makes up the glass bottom of the light. And here we change the value of light flickering state, and then we loop the code. Now looping codes is dangerous, but what we're doing is we're looping back to the bit of code that sets the intensity back to normal. The reason being, if we are flickering the lights on and off, we want all of the light flickers, when the lights stop flickering, they must all be at maximum brightness again. This code runs individually in every single light, but those calculations are done externally and then sent using the mains power event dispatcher, so that the player blueprint can talk to all of them at once. You'll notice that this loopback happens as a result of whether the loop is finished, and that's also code that runs in the player blueprint, which we will talk about another day because this video is already going to be way too long. that's about the bulk of it. The last bit of code that I've left is really the simplest. This is the code that shows or hides the interact message. So when you walk up to the lights, it'll say turn light on or off. That is set here depending on whether the light is on or off. Here it sets the interact message, and then this bit of code here does exactly the same as all that complicated flickering stuff. But we checked firstly to see if the mains power is on. This event object interacted with is from the Blueprint Interact interface, which I think I've spoken about in a previous video, but as part of the series of me going deep diving into the code, I want to re-look at that just to make sure I understand exactly what's going on. And then the rest of this is pretty basic. We get the location of the light switch, and we play the sound of the light being switched on and off, and then we set the visibility of the little red light, the main ceiling light, and the emissive material that makes up the glass of the light. Reset the variable is light on or off. Store, this is important, store the value of whether that light is on or off in the game instance. So every time you do that, the game will go and talk to the game instance and say, okay, the player switched this light on, remember that in case they leave the map or we start a new day and therefore load a new map or whatever. And then here, like I said, we set the interact message and we send it to the feedback system, which is another whole thing that I'll get into in another video. And then we either increment or decrement the number of lights on. This is to do with the bit of code in the player blueprint that will actually cause a power failure if you have too many lights turned on. And that's pretty much it. Here's another piece of this bit of code just checks to see is the mains power on when you try and switch a light on. If not, you'll see here it'll play the sound of the light switch going on and off, click click, with a 0.5 second delay in between, just to give the idea that the player is actually trying to switch the light on, and then the feedback message will be sent, the power is out. Yeah, that's pretty much it. I'm realizing now that when it comes to the mains power, I'm not seeing the bit of code that plays the sound of the mains power box in the basement, and I think the reason for that is because I think that bit of code runs in the power box itself. Here's the blueprint for the power box. Mains power control. Yeah, there it is. Play sound at location. So when the power goes out, the sound will play. Whether you're in that room or not, that lever will move and the sound will be played, which I think is quite cool, actually. And yeah, that is about it for the lighting blueprints. Each lighting blueprint is custom because it's got to be shaped like the room. Again, I did mention this in another video. When it comes to the garden lights, I did things completely differently. I created one garden light. Let me actually show that quickly. I created one garden light like so. Just placed them all over the place and then used an event dispatcher to link the switch to all of the lights at once so that I didn't have to make a gigantic complex blueprint. And in hindsight, I should have done the same thing with all of the lights. But I didn't know how to do that at the time when I started making the original lighting blueprint. So that's the way the code is now. So here ends the video on the lighting blueprints. Like I said at the beginning, this is as much for my reference as it is for anybody else's reference, just to future-proof things in case I need to refer back to it later. I have a complete record. So in a couple of days, I'll make another video on another type of blueprint or another bit of code and break it down. And that's about it. As always, thanks for watching. Don't forget to like and subscribe.